Jake is.
All right, hey Emma,
like
this
the
is
fun
one
size
for the
candy
homework
bar.
assignment is at the top. This is combinations of functions. Make sure you write that homework assignment down. Here we go. This is going to be a really short section. We'll go through it really fast and then you have time to work. All right? Combinations of functions. We are adding, subtracting, multiplying, dividing functions. I'll leave that up there. Okay? So the deal here is that the thing that's going to confuse you probably is like they will write it as f plus g of x. Okay? That just means f of x plus g of x. You're just adding those two functions together, combining like terms if you can.
Is this
right?
fog and goff?
Yes, we're going to do fog and goff later. Okay? F minus g of x, you're subtracting. Okay? Okay, we'll get to it. Oh, right now?
Kind of.
Okay,
I did
go.
actually have to use this at work the other day.
You did?
Yeah, because
Hey.
we were having a clearance sale and it was already marked down 25% and then it was 50% and my manager was trying to tell me it was 75%. I was like,
No, it's not.
No.
Oh,
And she,
I love it. I love it.
I did get a dirty look, but
It's not.
I was like,
It's not. Right. That's exactly what composition functions. So that's what we're doing right here. Composition of functions is like the fog and the goff thing. Okay. And it's clear to see to you that if you have like something that's 50% off, right? And then you have a 50% off coupon, like it's not going to be free, right? Like that's obvious, but it works the same way with a 25 and a 50. Like it's not 75% off. So if you have something that's $100 and people are like, oh, it's 75% off, it should be only 25 and it's actually ringing up as like 30 or 35, they get pissed and they're like, it's like, no, they don't stack like that. They don't add them. You multiply and then you multiply again, which does not make it the same amount. So yes, composition of functions. Ha! Look at you go. All right, so there you go. All right, minus. The only thing I will say about minus is that if g of x is a like binomial or trinomial, you do have to distribute the negative through. So don't forget to do that. FG. FG, when they're right next to each other, a lot of people get this confused with fog or goff. F times G is just FG, written right next to each other. That just means F times G. So FG, multiply. F divided by G is F over G, okay? Or they could say G over F. The F does need to be on the top, the G does need to be on the bottom. And then a lot of times we'll designate what G can't be if we have a division, okay? So here we go. We're doing A, B, C, D for each one of these. Here we go. X squared is F, G is 2 minus X, and we're adding those together. So if you don't want to write all the work out, I don't care, that's fine. We've got this guy added to that guy, and we put them in put them in order and combine like terms if we can. So something like x squared minus x plus 2, yeah?
Yep.
Very good. Okay, that's very nice. Minus, we have x squared minus 2 minus x. So in that case, we have to distribute the negative, right? X squared minus 2 plus x, and put in order as x squared plus x minus 2, yeah? Easy peasy. Okay, multiplied x squared times 2 minus x. Distribute the x squared through. 2x squared minus x cubed. If you put them in order, it would be negative x cubed plus 2x squared, yeah? Easy peasy.
I don't think he's.
Will you take points off like we have like the number in front and then with like
If you have like the 2x squared minus 3x minus x
Probably not. Probably not. That's gonna be fine. Yep, yep.
It is the same thing.
But if you don't combine your like terms, I'm gonna take off. Like if you have like whatever.
what?
Like, come on.
Oh, you
Okay.
just put them on the
Okay,
website.
f divided by g is x squared
Do it.
over 2 minus x. In many cases, you will not be able to do anything. Like in this case, there's nothing I can do to simplify this thing, right? Nothing I can do. Except I also have to put what x can't be. What can x not be? 2, because I don't want to divide by 0, right? So I need to put that. Now, I'm going to put a little mini example up here. And let's say, for example, let's say I have x minus 2 over x squared minus 4. Let's say I have that going on.
You can.
That one you do need to simplify because the bottom is a difference of squares. X plus 2, x minus 2, okay? You cancel those out, so you get 1 over x plus 2, and then x can't be negative 2, right? Good? Yes? Okay, so that is the scenario when you do need to simplify, right? Like
So-
if you were to have something that looked like that, you would reduce and FOIL and or factor and simplify. What?
Why can't you have x over
What was the homework assignment?
What are you talking about?
Well, I couldn't call him sick.
Take this, like just
But
divide
then everyone would
myself.
talk about me.
Why can't you have x be 2?
You have to. We're not gonna talk about you the way it is.
You can't, because this is trapped by the minus. Like 2 minus x is 1 unit together.
So it's a plus. Is it?
Correct. They're
So
trapped as a
everything is
unit.
trapped.
They're trapped as a unit together. The only time you can reduce them is if you're multiplying. Like if that was 2x and not 2 minus x, 2x you could cross off an x, right? But 2 minus x you cannot,
Okay.
because that is a unit. That's a very good question. Okay?
Um,
Alright, moving on. What?
I was gonna say, up in the top corner, like, could you cancel the x squared and the x?
No. That's kind of what, along the same lines as what he's saying. The x minus 2, they're trapped together.
Okay.
Because of the minus. Same thing with x squared minus 4, those are trapped together, right? If this was 2x and 4x squared, you could reduce this and reduce one of those and then divide the 2 and the 4. Because multiplying you can reduce, but adding and subtracting, they're a unit together, so you cannot reduce them. Unless you have like the full pieces, right here and right here. X minus 2 can cancel off that whole thing, okay? Yeah, good question. Alright. Composition functions is when one function goes inside of the other. So like fog and goth, right? They will have like a little circle. This does like in fact look like fog, but usually the circle is like a little bit smaller. That is the composition circle, okay? And that means the same thing as like the parentheses. So I'm basically sticking g of x into the f of x function where the variable is located, right? Okay, I'm sticking that guy into there, okay? So we're gonna do an example of that. We have f of x is here and g of x is here. And this one is f composed of g, so we're sticking g into f. So this guy is going into f and we're plugging him in for x, right? So rather than having x plus 2 for my f function, I put 4 minus x squared into that spot.
Plus
And then
2.
I just simplify, right? Plus 2, right? This one we won't have to FOIL. The
So
next one we
x
will,
squared plus
right? Because it's x, we're
negative
putting
x.
just in for the x, right? X plus 2. So this would be negative x squared plus 6, and that is all, right? Now g composed of f, this is the reverse. Now this is the ugly part where we have to FOIL, right? We're taking this and we're sticking it into the x squared. So instead of 4 minus x squared, we plug the x plus 2 in there, right? Okay. Do you know off the top of your head what x plus 2 squared is?
X squared
X
plus
squared
4x plus
8x,
4.
oh,
Plus 4x plus 4, x squared plus 4x plus 4. But then we have to distribute the negative through. So this actually becomes negative x squared minus 4x minus 4, right?
Oh my.
Okay, and then we combine like terms. So we've got negative x squared minus 4x,
That's it.
and then the 4 and the minus 4 cancels. So that's it. Yep. Good. Okay. So pay attention to which one goes inside of the other one. All right. Sometimes one way is uglier than the other, right? Okay. Good. Are you doing okay, Rach? Okay. All right. What happens if they say like g composed of f of negative 2?
Plug
I
in
don't
negative 2
know.
for x.
You plug in negative 2 into g or f first. Which one?
Into
G.
f.
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 We work backwards, right? We have to evaluate what f of negative 2 is first, and then we stick that number into the g function, okay?
So
So I'm gonna evaluate f of negative 2, okay? And f of negative 2 means we're plugging negative 2 in, so it's negative 2 plus 2. And so f of negative 2 is 0. Now I'm going to find g of 0, okay? And that is
Ew.
4 minus 0 squared,
What?
which is 4.
Whoa, 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 whoa. Oh, right.
Yeah?
Yeah.
Okay, so what's the answer?
4.
Just 4, not 0 also. 0 was like my intermediate step, okay? So 4 is my only answer, because I want one full answer for the end of it. 0 just gets me to that spot, so 4 is the only answer. Happy with that? Yeah. Okay, alright, good. Okay, finding the domain of a composite function. Here we go. The domain of x squared minus 9 is all reals, because I can plug in anything I want to. The domain of g of x is not all reals, however, because I can only plug in certain numbers in for x, because I don't want to divide by a negative, okay? They are asking me to compose one inside of the other, okay? F composed of g, so g is going in to here, right? G is going into the x, so instead of x squared minus 9, I have that, this stuff,
And the square goes
inside the square, right? Okay? And then, the square and the square root go away, like that. 9 minus x squared minus 9. So, final answer is negative x squared. Now I'm going gonna give you something that's really gonna piss you off.
Hold on. Calm down.
That is the composite function, correct? Negative x squared is what he reduces to.
Yeah.
Okay, now, his domain, what am I allowed to plug into negative x squared?
Whatever you want.
Whatever I want. So his domain is all reals, except when you're doing the domain of a composite function, you have to look at the individual pieces as well, right?
Okay.
So what went into that composite function? This guy, his domain is all reals, fine. But this guy, we already said, he is not all reals. We have to decide what x can be and what x cannot be. So I usually set this equal to 0, right? If I set the inside equal to 0 and subtract the 9 over, I have negative x squared equals negative 9, which means positive x squared equals positive 9. And if I take the square root, what's the square root of 9?
3.
And
Plus minus 3.
plus minus 3, x equals plus minus 3. So I'm going to put that on a number line, negative 3, positive 3. We usually use a number line. Over here, let's do negative 4, let's do 0, let's do positive 4.
It's on both sides of the threes.
Okay, if I plug in negative 4, negative 4 squared is 16. 9 minus 16 is negative. I don't want a negative inside the square root, so that's not going to work.
Why would you have to put it on number line?
Because you have two critical numbers, so you have to decide which range
But
works.
you know it has to be positive, so the negative one wouldn't work anyways.
Right.
So why do you need positive?
Cause sometimes we don't see it right away.
Yeah. If you can see it, don't put it on a number line. I don't care. I'm just writing out all my work. 0, if you plug 0 in. 9 minus 0 squared is 9, and that works, right? If I plug 4 in, 4 squared is 16, 9 minus 16 is negative, so that does not work, okay? So the domain for this is negative 3 to 3. If I use interval notation, is it brackets or parens? Brackets, because I can include negative 3 to 3. So the domain of the entire composite function is all reals. The domain of just this piece is all reals. The domain of this piece is negative 3 to 3. So what is my domain?
Negative 3, 3.
It is the restricted one. Whatever one is the most restricted. So this guy is going to trump all of the other ones,
So,
right?
like, hey, whoa, time out there, bud.
So the whole thing domain is negative 3 to 3. Yes, sir.
What if you have two restricted that don't correlate? Is it just
Good
no
question.
answer?
So let's say, here we go. Let's say this one says, just for example, I'm giving you like a stupid example. Let's say this one says x has to be less than or equal to 1, right?
Yes.
Okay? And this one says x has to be less than or equal to 4,
Nope, messed up.
okay?
Because it should be.
Less than or equal to 1 or less than or equal to 4, right?
Yeah, the less than
So
or
I
equal
put them
to
on a
1.
number line and I'm saying that one of my functions says that I am only allowed to plug in numbers that are less than or equal to 1, right? And the other function says I'm only allowed to plug in numbers that are less than or equal to 4. Which
Go
one do
with
I have to
1.
go with?
1. But what if they go the
No,
opposite
no,
direction?
no. I go with 4.
Why?
Why? 1 is
But
the
it
most
covers
restricted.
more numbers.
1 is the most
You
restricted
can't
though.
just skip
Hey.
Wait a second.
Ha! You're done.
X has to be less than or equal to 1. So here's the deal. This will work for 2 equations. This will only work for 1 equation,
Mm-hmm.
right? I'm confused, like what can x be and what can x not be? X has to be less than 1, x has to be less than 2, or less than 4.
Just put 1 because it works for both.
It has to be less than 1.
Okay, but what if the two
Right,
arrows
because
go,
if it was, okay, let's if it was like, let's say 3, it would work in one of the equations but not in the other. Does that make sense?
Yes.
So you would have to go with x is less than or equal to 1 because that's the most restricted.
What if
Yes.
the arrows go in the opposite direction?
Then you would just combine them together and say it has to be less than 1 and greater than 4.
Cause
You
then
would
you're
combine- you
restricted to only,
You would combine them together.
You see that?
I can't see.
So if like this was greater than or equal to 4, it would be both of those together, right? That would be your domain, right? Both of those together, okay?
You like to.
Good?
No. What if, okay, you have your stupid little chart thingy,
Mhm,
your
mhm.
line thingy, and let's say it goes left of 1 and right of 4.
Left of 1 and right of 4.
Yes.
Then it would be left of 1 and right of 4. That whole thing would be your domain.
Okay. So we're like, okay.
Yeah, like I would only be able to plug in numbers that were
Are you Gru?
Okay.
either over there or there. Alright, that was a lot.
cube
Alright, last thing.
question.
This is my favorite part.
Win.
You gotta listen to this because this is my favorite part.
This is not fun.
This is my favorite part. Oh, it's like a puzzle. I love this. This is my favorite part. Ready? Ready. This is my favorite part. Listen to this, okay? When we get to derivatives and antiderivatives, actually, in chapter 6, we start to do something called substitution. It is not like substitution and elimination, but it's called substitution by integration by substitution, okay? We start to look at composite functions, like what is making up functions. And what we want to do, we want to break this down into two functions like f of x and g of x that I am somehow composing one inside of the other to create this masterpiece right here. So I look at like the inside pieces, like what functions are going in there, okay? And so there's a couple different ways that I can do composite functions. Some of them have different, have a couple different answers, right? And so we're gonna look at a couple different answers. You only have to put one of them down, but if we're looking at like pulling this apart, right? We could say that f of x is 1 over x, right? Like 1 over this junk right here. And then we could say g of x is the bottom, x minus 2 squared. Okay? So that if we do it that way, and we do f composed of g of x, or we do fog, f composed of g of x, we would take this guy and shove him in there, right? And he would become that thing, right?
Guys, I don't like
Yeah, it's like dissecting it, right? Okay, finding components of composite functions. So we would define f of x as this guy, we would define g of x as this guy, and say we're doing f composed of g of x to get h of x, right?
Could you do it?
Now, what else could we do? Go.
1 over x squared.
Oh, so he's saying we want f of x to be 1 over x squared, okay? And g of x is going to be what?
X minus 2.
Just x minus 2. If I take that guy and I shove him in just for the x, would that give me the same thing? Sure, that's why there's more than one answer, right? Okay, so you could do it that way as well. So you're picking apart like the pieces and the different functions that happen. That might be the only only option that you have, I think. Just those two options. But some composite functions have many different ways that you can like shove them together and they will still work, right? Good?
Yeah.
So there's two different answers of how you can like compose them together, right? Those are kind of fun. This is like my
So
favorite part.
would you say it's usually the one in the
Fun.
parentheses?
What?
It's usually what's in the parentheses.
Yes.
And
We
what's
have to
not in the
do
parentheses would be
four
that
steps.
plus x, which
Right.
would be in the parentheses.
Question,
Right.
Mrs.
Yeah.
Commodore.
this.
So I have this narrowed down to the cube.
Okay, hold on just a second. Anybody else have questions before I stop the video? I'm gonna stop the video and then I'll answer Marcus's question. Okay, bye, Emma.